Yes, so good evening, everyone.
Hi everyone. Hi, fine day. Hi, fine.
Yeah, I can hear you.
Okay, thank you. Um, so can we kick off for now, or is there anything going on?
You can kick off.
Now, we can kick off.
All right then. All right, thank you. So, good evening, everyone. Glad to be here once again. Ah, it's been a long ride, and we are at the end of the boot camp. So, yeah, so glad. And I think this will be my last lecture. Yeah, I believe. So, yeah, it's a bit of nostalgia and all that. But yeah, it's been fun all the way. I do want to say thank you all to everyone that has really helped. Everyone that's supported, everyone that's posted. I mean, like all of the posts have been most of what has been helping us. It has been a big motivation for us. So yeah, um, thank you all so much. Uh, okay. So let's get into what we have today. like I'm in very low spirits, but yeah, and that's what we have. So we shared a paper. Let me share my screen. Should be presenting. Why? What's this? What's this? Share. All right, guys. I believe you guys can see my screen. If I could you help me confirm that?
Yeah, I can see your screen. Can you hear me?
Okay. Yeah, I can hear you. All right, so yeah, we shared the paper. Please could you guys like comment in the chat for those that saw the research paper we said you guys should discuss in teams. Let me know in the chats if you were able to go through it with your teammates or you had to do it individually. So yes, kind of like some feedback from what we've been doing. Yeah, so someone said yes, Sumaya said yes. Who else was able to go through that paper? This I saw the PDF, so yeah, Mike, did you go through it? Okay, yes. Samson said he was able to get through it. Who else? Okay, Muhammad Al. So as a type yes, let me know if it was easy, if you understood it. Did you go through it with your teammates? Okay, Kalim says, yep. Or did you get it? Like, what was the feedback? Let me just see that in the chat. So before I get into what we have for today. Okay, Delay said no, he wasn't. Who else? Okay. All right. It was complicated for me, which I thought to work it with the team. Okay, that's like all right. So we'll be going to now we're in the advanced part of RAG, so to the course. We're in the advanced part of RAG. Actually, we started the advanced part of RAG last week. This is week 6. Sorry, 2 weeks ago. We started with monitoring, where we had the engineer from LangChain that taught us how to do monitoring with Langsmith. Then we moved on to query rewriting and data routing. And yeah, we're here now. So these are like advanced RAG techniques. There are so many of them. Self-RAG is not the only one. There's corrective RAG, there's adaptive RAG, and many more advanced RAG techniques. So, but we'll get into, will I say, let's say like one of the basics or one of the most popular ones. So self-RAG. Yeah, so what is self-RAG? What do we say self-RAG is? So self-reflective RAG retrieval is a variant of RAG where the LLM does not just generate an answer once, but also evaluates and reflects on its own outputs or the retrieved documents before finalizing a response. Hi guys, please give me a minute. Let me get some water, please. Back. Okay, so yeah, self-reflective RAG. It's a technique where, so kudos to everyone that has been able to build something so far. Big thumbs up. Now we're moving on to the next step. It's self-reflective RAG is the technique where your LLM, your RAG application evaluates its response. Let me get my camera. Yep. So your LLM evaluates its response. So it doesn't just spit out an answer, it evaluates what is given to you. That's what self-reflective RAG is. So let me go through it. So self-reflective RAG is a variant of RAG. So it's a type of RAG or a technique where the LLM does not just generate an answer once, but it also evaluates and reflects on its own output or the retrieved documents before finalizing a response. So it introduces a feedback loop where the LLM retrieves documents from an external knowledge base, generates an initial answer using those documents, self-evaluates the answer, and checks. So it self-evaluates the answer. That is by checking for factual grounding, completeness, usefulness. It also checks if it is hallucinating. It depends on what you want. It depends on the process. It's just like a framework for building RAG applications. And then it reflects and revises. If I may, please, could you help remove annotation, disable annotation? Okay, let me do that myself. I have disabled it. All right. Okay. So yeah, so it reflects and revises by either improving the answer, reformulating the query. So whatever the person puts into. So we've gone over query rewriting, right? We did query writing last week. For those that missed the class, the lecture is on our YouTube channel. So either it decides, okay, instead of just spitting this answer, let me rewrite this query. Maybe I'll get something better. And then it also rejects unsupported claims. The process continues until the model produces a response that passes its own evaluation criteria. So, excuse me. So take it like this. I build my RAG response, my RAG application, and before the LLM spits out a final answer, it kind of like does so many things internally. And one of the things it does internally is it first of all evaluates the documents that were retrieved. So we know the normal naive RAG. That's why it's called naive RAG, because it's just there. There isn't any extract. So this is where the advanced RAG part comes into play. So I retrieve my documents and then I retrieve my documents and then I pass it to the LLM. Say, hey, how far? This is the question. These documents that have been retrieved, are they similar? Sorry.
What I'm
Hi guys, sorry about that. So, as I was saying, you retrieved the documents that you retrieved. I passed it to the LLM. Oh, this is my question. These are the documents that I retrieved. Is it good? Is it sufficient for this question? If he says yes, then it passes it on, and then the next thing is for it to generate. So the retrieved documents have been approved by my LLM. Next thing for it is for it to generate a response, right? And then after doing so, once it generates a response, I now also do a reflection on that. That's where the whole self-reflective RAG is. So I asked the LLM, look at the question that was. So this is the question. This is the answer that the LLM generated. Did it hallucinate? Is the answer relevant to the question? If the LLM says, okay, good, great, you're good to go, then I pass on to the next thing, right? If it says no, then I can now decide, okay, maybe I need to retrieve a better document, although it has already approved that my documents were good. So if it says no, maybe what I have to do is rewrite the query and then pass it again with the documents into the LLM and get another generation, and then I pass it again to the part of the process that is going to also evaluate my answer for hallucination. And then when it evaluates my answer for hallucination, it says, okay, yeah, this is good, and then it now spits out the answer. So let's move on. Key aspect of self-reflective RAG. So one of the key aspects of self-reflective RAG is the reflection step. The model acts as both a generator and a critic. So it acts as both a generator and a critic in the sense that once it generates a response for you, it also now criticizes his response against what was needed. So it says, oh, this is the question this user asked, this is what was generated by the LLM. Is this in accordance to, is there hallucination? Does it tally? If it doesn't, do whatever it is, probably rewrite the query or retrieve better documents. Then another aspect of it is an iterative improvement. So instead of one-shot answering, the system loops until the response is acceptable. So instead of just asking it a question, the system is going to iterate over the question, that was asked. It's going to iterate over its process until it passes that response and say, okay, this response is good. This response from the LLM is good. And another aspect is self-reflection. If the model detects gaps, unsupported claim, irrelevant docs, or hallucination, it corrects itself. So yeah, I think. And the difference between this and the standard or naive RAG is basically the self-assessment. There's a reflective processing, and the naive RAG, there's nothing like that. You just give it your answer, it does your retrieval, feeds the retriever, irrespective of whether the retriever is good enough or not. Even though there's a ranker, irrespective of all of that, it doesn't care. Just pass it from query, retrieval to maybe ranker, and then from ranker back to the LLM, and from their generation. That's the end. For self-reflective RAG, it assesses its it assesses what it's good for, basically. It assesses its processes, responses before it gives you a response. Then what are the benefits of self-reflective RAG? So because of this reflection process, you're going to get better accuracy, better response. Another thing is you can also implement guardrails. So a user can input something and the LLM response can be guarded, basically. So it can say, okay, so it can assess that user's into one place. It can also assess the user input. Is this question this person asking me related to what I am? So if you build an LLM, let's say you build a flight assistance RAG, and I come on your distance and I'm asking you about who is the GOAT between let's say Mbappe and Pepe or something like that. And the LLM is going to, you say, I'm a flight assistant, this thing. And then instead of it going through the whole process of even doing the whole retrieval, it will just respond to you with something like, oh no, I can't answer this question. That's not what I'm about. So so that's what we call guardrailing. Guardrail is like kind of like protects what the LLM processes. And then also increase adaptability. So you can adjust it depending on whatever process you want. And so you can adjust it depending on whatever process you want, in the sense that it could be that you need to rewrite the query better, Also, it could be that you need to retrieve better documents. And yeah, let me just show you. Yeah, so we're going to go into the labs right now. And all right, so so let's do it like this is like an overview of self-RAG. So the question is asked. We have the retrieve process, right? The normal retrieve process. So the retriever, we're calling it nodes for now. I'll explain why we're calling it nodes when we get into what LangGraph is about. And then when we retrieve that, we pass it to the grading process. So it is graded. So if so now the next process is this doc relevant or not? If it is not relevant, we send it back to rewrite the question node. So if after grading the retrieved documents, we see that, oh, this thing, what was retrieved is not relevant, we rewrite the question and we send it back to that retrieve node. So we rewrite the question and go and do another retrieval. Maybe if we have a better question, we'll be able to, implement better retrieval as well, get better docs. But if it is relevant, we can now pass it to the generate node. So we can pass it to, all right, now, since the documents are relevant, now generate. That is where, the normal process where you feed in your context and you feed in the answer. So you tell it, oh, you are this and that, answer this question based on this context. Now, once you generate, what we're going to check next is the next reflection process that is going to happen is this hallucinating or not? So if it says it is hallucinating, we go back because we don't have to go. So once it says it's hallucinating, we don't have to go back to rewriting the query or to generating, to retrieving more documents because we've passed this process. Do you get? We've passed this. So we know that the issue is not with our document. The issue is with our LLM. So we go back and then we kind of, we generate a new, we prompt it again to generate a new response. One step that you can even add here is you can try generating with a different LLM. So I'm going into the labs very soon. And then, so if it doesn't hallucinate, next process is, does it answer the question correctly? So if it answers the question correctly, so this hallucination process, we are comparing it against our docs. So this is the response. Is this response related to the these documents that were passed into it? And then if the response is based or grounded in those documents that were fed, we say, okay, no, it didn't hallucinate. So next thing is we now pass the question against what was generated. So if it says yeah, what was generated is it answers the question, then we spit out that answer. If it says no, then we likely have to start the entire process again by rewriting that query and there and there and there. So yeah, that's it. So let's get into the fun part. So yeah, this is the labs. I just want to see a big, so how can I carry this to the top? Yeah. All right, so let me install all of this again. So most of these docs are from LangChain and this guy on YouTube. I can't remember his name right now, but yeah, yeah. So I'm installing all of this. You guys know the process now. Install LangChain, install LangChain Community, LangChain Core. I mean, you know all of this. So we are not new. I mean, I feel 6:35. I'm looking at time. Why this is loading. I feel very glad. I remember when I started teaching, so many things were very hard. So I'm just saying this why this is loading. So many things were very hard in the sense that, I had to break things very down, like to very little details. Why did the sieve feel? I had to break things down to like very little details because, um, most of the audience didn't understand what I was saying. And I think it's really fulfilling to see how far you guys have come and to see the growth that, there's nobody in the chat asking about, oh, what is LLMs? And even during our keynote sessions, I see a lot of people ask brilliant questions. People like Mike, Emmanuel, Mina, Fidel is Abuki. I think Fidel is from Kenya. I think he's the lad from Strathmore. Yeah, I see like people ask like very brilliant and intelligent question, and it shows like people that started with little to no knowledge about stuff like this are, they're now going out of their way to learn all of these things. So yeah, it's really fulfilling, it's really exciting. Um, I'm so happy that I don't have to like explain everything again. Oh, I can just say, okay, we've done this and this is what happens. And you guys taking time to install. I think my internet is unstable. If I can hear me, am I still on this call? Raf, are you there?
Yeah, I can hear you. Can you hear me? I can hear you. Can you hear me?
All right. I thought I got cut
You
off
can
at one
hear me.
point. Yeah, I can hear you. I
Can
thought
you
I
hear
got
me,
cut
Victor?
off. Yeah.
So I don't know. Maybe at the point people feel that they couldn't hear you, but I can hear you overall. So it might be there then.
Okay. Gracias. Okay, so this is taking too long. Um, I will surely cut this waiting time out in the when we upload the recording. But yeah, so I've gone over this. Maybe I should have been explaining this and been studying it then. But yeah, I don't know why this is taking long. What's installing that's taking this long? I think it's sentence transformer. Well, so yeah, I've gone over this. Let's just get into it. So yeah, I'm importing my Grok API key. I have this imported. So in the whole process, let's start with the retrieval part. Seeing this. So we're going to load in our documents. So these three papers, these three posts, I mean. So one is on prompt engineering. I just hope this doesn't fail. Yeah. So we're going to be loading all of these things. So it's not my network. It's probably taking too long. So we load this in and then we do our normal chunking process here. Set up our embeddings and we split our document and then we load it into our Chroma database. This is taking too long than expected. I just want to be sure it's not my network. So it's not my network. Probably installing too many things at once. Yeah. No, let me even stop it. Like it's okay. Keep install. All right. So yeah, we do our regular chunking here. We install these. Actually started from where it stopped. Let me try and remove. Let me try and remove the sentence transformer. All right. And that's what's taking time. Okay. Oh wow. So apparently it's already even installed safe. So it's probably my network that didn't catch up. So yeah, we're doing the regular loading our env file, and here we are retrieving our document. So this is the retrieved document. So we're just loading 3 web pages and we're indexing them into our Chroma vector store and setting up our retriever. So let's run this. This shouldn't fail. Okay. Yep. So while that is running, so basically it's just indexing. While that is running here, we're going to be setting up our LLM. So the regular, you guys remember what this is. So yeah, we're setting up the base model. If you remember from, Pydantic output parsers and all of that, prompt templates and all of that. Yeah, you should remember this. We're setting out a structured output for our LLM, basically using Pydantic. So we're using the base model from Pydantic, and we're defining the grade document. So this is the structured output parser. So what is this? Is a binary score for relevance check on retrieved documents. Let me, so that I can always reference this. So what we did here is this retriever node. So let's call every process node. Let's call every process node. And I will explain in a while when we get to LangChain, when we get to LangGraph. So let's call every process a node. So this node now for the retrieval, that's what's happening here. Then the next node is we are setting up the LLM that is going to grade our response. So this is the retrieval grader. We do the regular, let me even be running this. So we do the regular, so we're setting up, shit, it's failed. LangChain Grok. No module LangChain Grok. Okay, pip install. Sorry guys, let me install LangChain Grok. Pip install LangChain Grok. It should work. Yep. All right, should highlight this. So yeah, while that is installing, so let's run this again. What was the issue now again? Okay, I think it's how the LLM is being set up. Why was the temperature set? Well, sorry guys. So we are setting up our base model. So we're saying, so what is this basically? It's what we're going to pass to our LLM to say your output should be structured in this format. So basically your output is a binary score. And what's the description for the binary score? So documents that are relevant to the question, yes or no. And then yeah, we're setting up okay, this is where there's an issue. Charts grok. Chat grok. Sorry guys, let me just LangChain grok chats. This is all they have on their sites. I think my code is messed up. Okay. All right. So if I set this to this code should run. All right, good. Still failing. Invalid API key. Invalid API key. API key equal to oh, I see the issue now. Yeah, I remember I deleted my my Grok keys. So yeah, let me just use. Sorry that I'm just setting this up right here, guys. Really sorry. I ran this before and created new API key. MMM. Need to set this up. Verify no issue, man. So I'm just going to, I'm just going to put this inside the code, and then after the class, I'll just delete it. All right, great. So yeah, I'm setting up my LLM. So back to us. So before we set up our grid documents, the pedantic, the output pass, how we want the output to be passed. That's what we're setting up here. Using pedantic, then define my LLM. Now I'm going to now pass that structured output. So using the LLM, the structured output from LangChain, I'm going to pass in this model. So basically what this Pydantics model is going to tell our LLM is that make sure that, so it's going to make sure that your response is yes or no. Don't give me any other thing that is not yes or no, basically. And this is my prompt. A grader assessing relevance of a retrieved documents to a user question. If it does not need to be, the stringers test, the goal is to filter out, retrievers that are not useful and all of that. So basically, this is the LLM, this is the retriever grader. So we've done our index and all of that. So let's pass in our question. So this is the prompts. We're defining our prompts using chart prompt templates. You guys know this. Then we're designing our chain. So we first of all pass our question into the prompt template, which is this, so that we can also what's it called again? To format our prompt template, and then we pass all of that into our LLM. So this is my question, agent's memory. Then we do our retrieval, and this is our retrieval. And this basically is like bringing out just the page content of every document. And here we invoke it. So let's run this. So so you see, okay, I already ran it, and see the answer it gave me yes. So it's relevant. So this is where it's saying, oh, are the retrieved documents relevant? Let me try and let me put something here that I know is not Cristiano Ronaldo and Naruto Uzumaki. So it's going to do the regular retrieval, but then it's not going to be. So I'm expecting the LLM to say no. And please don't disappoint me, guy. So yeah, see the response. I hope you guys can see it. I hope my screen is not so small. You see, no, it's not. All right. So what's the next step? Let's go back to agents memory. So those 3 web pages, they were talking about agents and memory in RAG and all of that. So we got yes. So the next thing is, all right, so you've passed the test of the documents that were retrieved, they are relevant. Now let's generate a response. That means I can work with your documents. Let's generate a response. And so yeah, we are pulling, I hope this is going to work. So yeah, we're pulling like a prompt template from Hugging Face. So there are also predefined prompt templates on Hugging Face. All you just have to do is put import hub and then pass in the ID basically for pulling that prompt template. Right. So all right, so yeah, I define my prompt templates. In fact, let's kind of like run that so we can like see what it's about. Print prompt. I just hope this doesn't break. I haven't tried this before, but I want you guys to see. Okay, it did break. Whatever. But yeah, we're defining our prompts. And then we're passing it into this. Okay, see what I can do here. Oh, it's workable. So let me run this. I'm sorry, I'm trying to run that code. Let me stick to what's works, guys. All right, so I define my prompt. Okay. This is what's causing the issue again. I have to decide if this. I have to set up my LLM again. So yeah, you can choose to like change the model. You can use a different model for every step. Do you understand? So the best thing you can do here is like research what models are good for what, and then if you see that okay, they said Meta's model Llama is good at generating text, you can use Llama for this generation process. If you research and you find out that OpenAI is better at judging, at analysis, you can use it to judge your retrieval. So yeah, I'm just going to go, since I've passed that step, I'm going to go ahead and generate the prompt. I'm going to go ahead and answer the whole stuff. So let's go here. So let me run this. So yeah, it gives me a response, but I want to show you guys this prompts. I want to show you guys this prompts. Yeah, prompts dot invoke. I want to show you guys what this looks like. Yeah. Okay, didn't break. Okay. So let me comment this out and run this. So, okay, so see what the prompt templates we pulled from Hugging Face is. I should have dropped the link here, but yeah, just start pulling prompt templates from Hugging Face. You see it. See what I got here. No, I'm printing the wrong stuff. I want to print this and print this. Yep, let's run this. All right, so yeah, see the prompt template. You see, there is nowhere here that we defined any prompt template. We just pulled the one from Hugging Face, and this is what we put. You're an assistant for question answering tasks. Use the following pieces, blah 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 blah, and it goes ahead to fill in whatever. So yeah, you can do that. I just wanted to show you guys that you can pull in prompts instead of crafting. You can just pull in already written prompts. So now we've gotten to our generation part, agent memory, and the LLM has given us, okay, so the user is asking about agent memory, and it needs to, so yeah, so this is, oh, wow. This DeepSeek R1 has the reasoning part. So this is what came out here. And this is the answer that it gave me. This part is the reasoning part. Oh, they've taken my lights. Let me off my camera until the gen comes on. All right. So yeah, this is the response. And next thing we have is the hallucination grader. So now that we have our answer, the next thing is to check this question against the documents. Did the LLM hallucinate? Is what was generated rated on the documents? Is it like grounded in the documents? Since we are sure that, okay, yes, our document is good, no problem with the documents. Now we want to check that, oh, did the LLM hallucinate? Because even when you get the right document, the LLM can be, daft enough to hallucinate. Maybe the model you're using for generation is not good enough. Do you understand? So, um, so yeah, here we define another output parser, and we are calling it grade hallucination. So it's a binary score basically. So the description is answer is grounded in fact, yes or no. And then we have our LLM here once again. All right. So yeah, my journey is on now. All right. So we have our sorry, let me copy the LLM again. So yeah, we have our LLM again defined here. We're passing it the structured output that we want our output should be yes or no, nothing else. Don't give me any other thing. And then, so here we're defining the system prompt again. You are a grader assessing whether an LLM generation is grounded or supported by a set of retrieved facts. And so here we're passing our system prompts, which is this. And next thing is we also set of facts, we're passing in our documents here and then LLM generation. So next we're going to pass in what was generated and the documents that were retrieved. So let's see if we get, so the hallucination the hallucination grader goes ahead to say, okay, yes, is good. So let's move on to the next step. Now, remember that if at any step it says no, we are going to go back to whatever. So if it was at the grading of the retrieve documents part, I said, oh no, we're going to go to rewriting the query and then now going back to doing another retrieval. And then next is the answer grader. So this is since we've passed, okay, so it was the answer was based on the document that it didn't hallucinate from the retrieved context. Let's grade the answer against the question. This is the next step now. And so here again, we are defining another Pydantic output parser. And here it addresses the question. It's still the same thing, binary score. Your output should be in yes or no. So notice that when we always define this model, this output model, we are always passing it. So please don't miss this step. We are always passing it to the LLM. This with structured output is what is going to ground the LLM's response, no matter what. And then, this is our system prompt here, a grader assessing whether an answer addresses or resolves a question, give binary score yes or no. So here we're passing our system prompts here where we're creating our chart prompt template, passing the question and passing the question, what was generated, and then we define our chain. So the question that we got from here, we pass it here, and then move it over to the structured LLM grader. And then when we run through it, it's fading. I don't know why. Please adjust your prompt, see field, invalid error code. I don't know what's the issue here. Let me run this again. Wow, this just ran correctly. So why did it fail now? Oh, shit. What happened? 400 error message. Why did it just fail? see the model, accept and run. Still didn't work. It can't be because I'm initializing it. Authentication error. I guess my API key has been blocked. Oh, what? Sorry, guys. Let me see. This is not working. Okay. Well, for whatever mysterious reasons, we're back. All right. So doing the same thing here. Why are you feeling? Fail to call function. Please adjust your prompt seed field. All of this thing worked before now. Yeah. Let me see. It's from this. Well, whatever, sure. Let me leave it about. But you get the mess. You get the entire gist. So if the response here is a yes, then we can now push the answer to the user. And then this is just the part that handles the entire, if there's a part where you have to write the query, this is the stuff that handles it. And please don't spoil. Okay, this works. I have no idea why this didn't work, but yeah, this is just the part. So we've seen how the whole building stuff works. So if we pass it through here, I believe it's something that is wrong with. I really don't know what's wrong there. The it's showing a 400 error. Whatever is the issue, guys. But yeah, so if when we get, so if the answer, if the response is a yes, then we push it to the user as okay, yeah, good. And this is just, the question writer part. Now, so someone might be asking, like, how do we now put all of this? So you can do this manually with, different runnables and LCLs, that is LangChain expression language, that pipe operator. But one of the most efficient ways to build this is LangGraph, and that's where LangGraph comes into play. We're going to cover LangGraph in depth more later in the course. Sorry, later this week. That will be our last lecture. But before that, let me just give you guys, an overview of what LangGraph could be. So, yeah, we have LangGraph. So take, for example, so all these things that we built, let me finish what we built. How are we able to, connect all of this into one node? Let me use something that is screenshotted. Okay. No, not this. All right. Okay. All right. So what's LangGraph basically? LangGraph is the higher level of from is going from just a simple LangChain to orchestrating an agent, basically. It's a framework, it's a higher level framework for orchestrating stuff. And what sets LangGraph apart is what we call states. So if you see that in what we've been building so far, I have to like pass things down, pass it down, pass it down. What LangGraph can help us do is connect all of these processes, and then all of them now have access to the states. So I don't have to pass it. So one part of the process can update, another part can do something else with it. So let me use my presentation to, and this should present, yeah. All right. So now let's say you're trying to build a RAG agent that, has to go online and then do some research, or that has to go online and do some research, or do some calculations, use different tools or do different processes. How are we able to like, do all of those logic and all of those type of things? One way we can do it is through LangGraph. And that is where the concept of what we call nodes in LangGraph comes into play. We also have what we call states, and we have what we call edge, and we also have what we call the graph is the entire, the entire thing. So let me use that example. So back to this example, you see this single, this unit of a function, or this unit of your application where a function is called, so there is processing going on, where a function is called and processing is going on, is what we call a node. Now, this process that takes this function to this place, that moves this function, that connects, not move, that connects this node to this node is what we call an edge. So in LangGraph, an edge is what connects nodes together, This is one node, this is one node, this is another node, this is another node. And what connects all of them together? They are edges. These ones in pink here are what we call conditional statements. They are what decides what route do we take in the edge. Which edge are we following? So this is an edge. These two edges connect these two places. So these two edges connect this node to this node, also connects this node to this node. Now, this is a conditional in LangGraph that decides, oh, which way am I going to go? Which node am I going to move after moving from grade node? Where's the next node that I'm going to jump onto? And these are the conditionals that decide the edges for us, basically. And what else? And then state is just is a persistence storage for your graph, basically. So even when you see how, even when I'm in this part, even when I'm in this process remembers the question that was asked. And why is this so? Because the question that was asked was stored in what we call a state. And a state is, let's just say it's a DB. It's a dictionary that is persistent storage that every node has access to. Every node has access to, and every node can update your state as well. And if this node, so where this node updates, so where this node is, okay, so let me use a typical example. So let's say we are in this conditional, this conditional point, and then in our documents, we've already retrieved some documents, right? And we've saved that in our store, in our document store, and we now, okay, we get here and the answer is no. We now need to update our documents. This conditional step is going to help us rewrite the question, do another retrieval, and now update the documents that were retrieved. And then we go through the whole process again. By the time we get to this hallucination stage that compares the generated answer against the document, we're not going to be comparing it against the document that was retrieved before. We're going to be comparing it against the new document that have been retrieved. And why is that? Because it has access to the state, and everything can be modified in the state, right? I hope that's clear. So that's the concept of LangGraph. We'll go more in depth into it, but I just wanted to go into it so that we can be able to teach this self-RAG process. So let's go back to, and yeah, so this is a node. A node is a unit of computation, and an edge is a transition or a conditional that decides what is the next node I go to. And yep, that's about that. All right, so let me get to the notebooks, back to the notebook. So yeah, so yeah, I wrote what is a graph state. I'm going to upload this to our GitHub so you guys have access to it. What is graph state in LangGraph? Graph state is just the data connector that flows through your workflow graph. Each node in the graph takes the graph state, does some work like retrieval, and outputs an updated graph state. So every node takes in that state, it does some work, and part of its output is the updated graph state. So it updates, if it has to, it will update the graph, the state basically. All right, so yeah, this is an illustrative example, but let me get into this. So here we are defining our graph state, right? I need to install LangGraph. Sorry, I need to install LangGraph. Forgot to do that. Pip install LangGraph. All right. Error, could not find the version that satisfies the requirements from why? Pip install pip LangGraph. Oh, I got the spelling wrong. So it's a double G. Yeah. All right. So yeah, that should work. Yeah. So if you remember when we talked about LangChain, we said LangChain has so many architectures. They have so many parts or modules, so to speak. There is the LangGraph, that is for building agents. There is, the LangChain core. There's Langsmith, which we've already covered by the engineer from LangChain. That is for monitoring what we are doing. And also there is also LangServe as well. And there's also, yeah, those are like, but I think I'm missing one, but yeah. All right, so here we're defining our states. So this represents the state of your graph. These are the attributes. So the question that is passed in, what was generated, and then the documents that were retrieved. So it's a list of string. So yeah, I'm defining my graph, my states, and yeah. All right, so from here, I'm going to use the, so I'm going to define the nodes. So each of the nodes, and I would be referencing our diagram. Yeah, I'll be referencing this. So let's start with the retrieve node. So this is the retrieve node. This is a description of what it does. So first of all, it takes in, so it defines a variable, the question, and it retrieves what's the current question in the states, and then tries to retrieve the documents from that question. And before we get here, let me show you where that is happening. So this is where it is happening, where we do invoke. Yeah. So you know how we do invoke at the end of everything. So where we invoke this, okay, yeah, we're streaming it. But yeah, when we invoke the question, so we pass it. When we pass it, it's going to store in the graph state. It's going to be stored in the graph state, as a session, as a variable. So this retrieve node, this is it here. It's retrieving the documents that are relevant to the question in the graph states, and then it's going to return the documents and also the question. And then we also have the generate. So see how all of them are taking in the states. They're all taking in the states. And we have the documents, the generation part. So this one is just going to generate the answer. So the documents and the questions that were returned are going to be saved back into the states. And this one takes the states. It retrieves this is the generate node. Okay, this is the generate node. And then it takes the documents that were there, sets up, gets, and then runs the whole generation, rag chain.invoke, and, runs the whole generation stuff. The rag chain that we already defined earlier, that is prompt LLM output parser. So That's the generation node. Then this one is the grading this is the grade documents node, basically. Also takes in the states, filters the documents that were passed into it. And so for documents in this, it grades it and gives an output, yes or no, for each document. And then it returns. So what's happening here is for every document that was retrieved, it's going to grade it, yes or no. And then it's now going to filter. So this is where it passes it into that retriever grader chain that we already defined. And then, so for every document that the binary score output is, remember when we did that retriever grader, it gives us an output of yes or no. So for every document that the binary score output is yes, it filters through everyone that the binary output is yes or no. So it keeps the ones that are yes, and then it goes ahead to update the document states with the filtered document. So the ones that are relevant, it goes ahead to update that state. And this is the node for transforming query, basically. Again, it's always going to see how all of them, independent of where they are just going to the states and retrieving different, this one is retrieving the question, this one is retrieving the documents. And then that question writer that I showed you guys is running again. And what next? Yeah. So it's getting a better question for us, and yeah. All right, then next one is, this is one of the conditionals I showed you. So it's going to decide, should it generate, should it not generate. Let me be running this code as I'm going through them. So the state, this, yeah. So we have this is this to decide whether to generate an answer or regenerate a question. So, and then we also have the nodes to generate the grade generation. So this is the one for the documents against the question, this part, the documents against the question. So yeah, this part. Is the document retrieved irrelevant to the question that the user has? This is another node. And then here we're just basically going to build the graph. So let me run this, and I hope this doesn't break. So when you now want to run with LangGraph, this is how we start. We usually define the workflow. So we have state graph, graph states, where we're passing in that state that we already defined at the beginning. This one here, right? So this is going to put it into the whole LangGraph workflow. Now we have to add these nodes to our workflow. So we say workflow.add node. Now we define with this first argument is, what is the name of that node? Here we're giving it the node of retrieve, and we're assigning it the function name of retrieve. Whatever name here is, whatever name you use for the function is irrelevant. You can use any name, actually. What's most important is, what are you using to describe it? So we had another node, the one for grading documents, we name it the grade documents. We have the one for generating, we name it the generate, and also have the one for transform query, we name it the transform query. And here we are building the graph. We are setting the entry point for the retrieve. So the entry point, so this is going to be the first place, and then after that, we're adding an edge. So remember what I said about edge. Edge is what decides what is the next place that we go to. Do you understand? So after the retrieve, we pass whatever is retrieved to the grade documents, which we already added to the here as a node. And then we also now add, we define a conditional this thing. So it grades document, decides to generate. If it decides to generate, it goes ahead. So this is a conditional. It goes ahead to generate. If not, it has to transform the query and regenerate and do another retrieval. So if that conditional is passed and decides to transform the query, this is where it has to do another retrieval. Now, in a situation where, so when it does this retrieval, it's now going to, so since it does this retrieval, it's now going to go back to this retrieve, and then now go again to grade document, because we've already added this to the node. Don't worry, I'm going to print out what it looks like. And then this is where there's another. So in a situation where the option is to generate in this condition, so it generates, and next thing it grades the retrieved documents against it grades the question against the retrieved documents. And if it doesn't work, so it's going to check. If it is not supported, it's going to generate. If it is useful, it's going to end. So if it's useful, so after after generating and grading the question and document, if it is useful, it's going to end the sequence. So we use the end to show that, okay, this is the end of the whole workflow, and it's going to output the answer. Then if it is not supported, so that is if this grading documents and question, that is in this place, we already defined it here. So if in this state, what was outputted is that it's not supported, that means we need to generate a better answer. That means it hallucinated on the document. But then if it is not useful, that means the document is not useful to the question, then we have to transform the query. And yeah, and then whatever node it hits back again, we already defined it. So if it hits the generate part, that means we have to do another generate another stuff again and pass it through this again. Then if you hit the transform query part, we already defined transform query here. Yeah, we define transform query here, and then we do another retrieval again. So yeah, this is where we define the transform query. We define the edge, and then we do another retrieval. And at the end of it, yeah, we just compile the entire workflow. So I want to print, so I have it here. I want to print what it looks like after defining the workflow. Yeah. This is the code. This was the second lab that I was supposed to demo, but I believe I wasted too much time on this. So let me just show this code. Let me run this, and I hope this will run. So this kind of like going to, so this gives you like an overview of what your LangGraph process looks like. So you can use this to like be sure that, oh, you did the nodes very well. So here we do the start where the question comes in, we do the retrieval, and then we grade the documents. Now, there are three different, so this is a mistake where it's going to end. So sorry about that. But there are three different, supposed to be two options. So either it grades the document and then it is good, it goes back to, it goes to generate, and then from generate, if it is useful, it ends. If it is not useful, it tries to generate another, and you remember this generate is checking the hallucination basically. It tries to generate another one, and then if it is useful, it ends. And then if it is not useful, then it goes to transform the query. So in a situation where we have to grade the document, we can just from grading the document, transform the query, and after transforming the query, that is basically that step of rewriting the query. And then we can go and retrieve new documents, and then the whole process goes over and over again. So yep, let's run this. So yeah, it's printing each part. So I've passed in my inputs here, and I'm streaming the results here basically. So it's printing each part. So first of all, it retrieves, checks for document relevance to the question, grade document relevance. It's graded some documents, and it said, okay, the first grading of the document, oh, it was relevant grades. The next one was relevant. Now the next document is graded was not relevant, and I'm guessing it popped this one out as well. Next one was relevant, and then next thing is it's graded. It has already like graded all of the document. The next step was to generate, and after that you also have to grade the generation against the document that was retrieved. And if all of that pass, it goes ahead to give you your response. So this is another example. All of this would be in the stuff. So that's that for today. Today's class was longer than I expected. Yeah, I know I take too much time, but there was another stuff I was supposed to demo, but this one has the whole routing stuff, but there isn't any time. I'll just post it. Maybe in the next class we can like go over it when we cover land graph properly. So yeah, but I'll upload this to GitHub. So that's that, guys. If you have any questions, let me know. If I can't see, I still notice my camera is not showing. Okay. If I in there,
Yeah, hi,
Raf,
I'm here.
if you have any
I'm here. Can you hear me?
questions,
Ebuka, can you hear me?
yeah. I can. Yeah, I can hear you. So I can see a question in the Q&A, but it seems my Zoom has hanged. Let me try and rejoin. So, Raf, are you there?
Yeah, Ebuka, I'm here. I heard you. Ebuka, can you hear me? Yeah, Ebuka, can you hear me? Can you guys hear me on the call? Like, if anyone can hear me, can you guys like signify? Okay, Samaya, I see you. So before I guess Ebuka will soon come back in, I just wanted to make a few announcements. Like Ebuka said, this is probably the last lecture for the bootcamp. So I just want to make a few announcements. As I mentioned to you, the testimonial link will come, it will follow the email we're going to send to you of the recording to be there. So please, that's very essential. You have the opportunity to like, so we're going to like do like, I don't know what they call it. It's like a collage, like different pictures together of people that participate in boot camp. So the form you'll be asked to upload your images up now. Your testimonials also, um, your testimonials also would be, yes, there's a final hackathon. The testimonials will be asked of you. And then the video testimonial is probably the most important because we want to like create content, and this is going to be on our website. And I think this is very big because this is the very first ever bootcamp we've ever done. So you guys are you guys are literally the pioneers of the bootcamp journey of NSQ.ai. I know Ibuka is back, and I just wanted to mention one more thing. There's also going to be a call for volunteers who'd like to join NSQ.ai. We had a surge in numbers. Before the bootcamp, we were relatively like 150 to about 200 people. And now we jumped all the way to 1,500. So that means we need more hands. And so again, I'll add that form in the link today. So for any of you on the call, or if you're even joining via YouTube later on, it's going to the form the links, the forms will be sent in the description for the YouTube videos and in the emails that will be sent. If you feel inspired or would like to volunteer at NSQ.ai, please do yeah, fill the form. Few things I'll say, Ibuka, I know you're here and I know you want to continue, but few things I'll also say. There are many roles that are open, many leadership roles, but I'll tell you that it is not easy. It is very demanding, very, very demanding. And if you know this is not something you can give yourself to, then it's fine. But I'll tell you a little story about Ibuka. I hope he doesn't start blushing. Ibuka, can you hear me, please? I need to confirm that you can hear me because I want you to be able to hear me while I'm saying this.
I just go straight to the point. The long and short story is
Okay.
that since I joined
No,
NSQ.ai, I've been a superhuman
no.
being.
Ibuka, I'm going to tell the story. Ibuka, let me
Guy,
tell the
just go straight to
story.
the point. There's no time now.
Please, I need to tell the
Let me
story.
finish my
So you
lecture. There was a
guys,
question in the Q&A.
no, you want to run. Ibuka, you want to
I'm
run.
not
No,
running
let me
from
finish your
anything.
story.
Guy,
Oh
let's
yeah,
just
I
finish.
answered the question, Kiani. Okay, finish the Kiani, and I'll
So
see
what
you
was the
around.
question in the Q&A? I can't see it again.
Okay, so there are two questions. So Mike says, thank you for lecture. I think we have 3 days before the end of August. Is there anything you guys see or before the last day? Okay, I think yeah, so again we have two keynotes coming up on Thursday and Friday, and then Saturday, if Ebuka is confirmed, we should have a demo. Yes,
Saturday.
or is that still tentative? Yeah.
Saturday is for Landgraph now.
Okay, yes. So we'll do Landgraph slash demo. Yeah. So that's what I wanted to say. Next question. Yeah, Fidel asked, can the LLM overthink sometimes? If so, how do we handle the case? Very, very good question.
So if the LLM overthinks, yeah, that's the essence of self-reflective RAG. So if the LLM overthinks, you grade it now. You know that point of the generation part. So you grade the response that is this relevant? Is this not relevant? So if it's not relevant, you send it back to go and generate again. So that's the idea of self-reflective RAG. It's kind of like a way to assess what your LLM is doing. So yeah. If I want to talk about the hackathon.
Okay, yeah. So as you guys know, we're going to be collaborating with Tublian on this. Basically, you all have teams, and so your teams are going to submit projects together. This is important. Why? Because again, we need like collective participation. So for people that have issues that maybe my team members are not replying me, we can form a new team. That is going to it's available. So, but the key thing is try and build something together. Try and push yourselves as much as possible. Um, the hackathon basically the submission starts from tomorrow, but obviously I understand that nobody will start submitting tomorrow, but you have to September 3rd. So the hackathon opens from submission start from tomorrow and on the 3rd of next week. So you basically have like a week to put together something. So you guys have to work together, try and utilize all the skills that you've acquired in the boot camp. There's also going to be an email explaining. So when the submission is open and the link is available, I'll send it out via email. And you guys also see the things that we're going to use to judge you guys on. So there may be prizes. I won't make that commitment, but there may be prizes. But again, another thing I want to emphasize on, as you build, please and please and please upload it online. So talk about this is an idea. Day two, I had this bug. Day three, I learned about Langa. Day four, I learned about one thing I want to emphasize to you guys is lots of people don't know much about RAG. Lots of people, and I'm not talking developers, C-level executives. I keep telling you guys, it's important you tag everybody, tag your team members, tag Ebuka, tag Sai, put it on your Twitter, put it on your LinkedIn. From now to everything we do, put it there. It's really, really important. So you guys are going to submit as a team, but then you're going to all send your emails. And please do not allow anyone to do the work alone because you miss out. I can see a hand raised up, so I will answer. Because that you.
Yeah, it's me.
Do you want to say something?
Yeah, I just wanted to apologize. I know that so many people have tagged me and tagged Ifeanyi and tagged Sai. And I know me personally, I haven't reposted or responded to so many of them. I just wanted to apologize on this call. If you're part of the people that you haven't seen a response from me, I'm so sorry. I'm going to respond to everything by this weekend. Honestly, I haven't had chance to breathe. I haven't had the space to breathe, to go online or do anything. If you notice, I haven't updated my LinkedIn on some of the things that I should have updated on. So I just want to use this opportunity to apologize to those that maybe feel like I'm snubbing their stuff. So I'm not snubbing it. It's just that I haven't had time on my hands to go through social media or to even
Yeah, because
sleep.
we understand that you're really busy. Yeah, because we understand you're really busy. We forgive you. We forgive you. So before people leave, so again, emphasis on collaborative learning. For people who are watching via YouTube, I know there are people that say they have exams, no problem. We also take you into consideration. Maybe by the time you're doing this hackathon, it might be weeks, a few weeks after. we're taking you guys into consideration. Once you're ready to submit your project for the hackathon, you send Ebuka or myself a message and we'll know how we go about it. And as I said, certificates are going to be generated for those who submit, and maybe there'll be prizes for first, second, and third. But the thing I'll emphasize on, build in public, push yourself very far. Push yourself very far. What I desire is that somebody gets a job or something that they never expected from this bootcamp. So without ado, I'll tell you guys a story about Ebuka. Yes, so
Let me
yes,
tell mine.
Sumaya, as I mentioned, no, I'll tell you because I'm the one that can explain to.
You
So Sumaya
always
and Mike, if you can't reach your team members, you can form a new team. I mentioned that already. So Sumaya and Mike, you guys can form a team already.
and the
So
hackathon is a team something, so it's not like
yes,
the
it's not a
naive
one-man
rag.
army.
Yeah, and you won't be submitting naive rag this time around. It's advanced rag. So if it's naive rag, nobody would grade it for you. We'll send you an email that you sent another naive rag, build advanced rag. So yeah.
They will reject your project. Oh, so another thing I'm telling you guys a story. So I think we can stop recording at this point. Oh no, I'll leave it on. I'll leave the recording because I want people on YouTube to see it. So you guys, Ebuka reached out to he joined NSK the AI about a year ago, and I remember having out like I was one that interviewed him. Ebuka was so optimistic about joining the community and everything, and Ebuka worked with me directly as external relations officer. Ebuka was he wasn't pushing his weight, and they got to a point where I literally told the entire team. I was actually speaking to Ebuka directly that if you're not going to wake up, it's better you leave. And a few people didn't improve and they dropped off. And Ebuka was one of the few people that picked up and he changed. And ever since that, I've seen Ebuka grow. He has his own deficiencies as a person. And one of the beautiful things about leadership is that you're constantly pushed to stretch yourself, And he decided to take on more responsibility, pushing himself out of his comfort zone. And there was a point where at the beginning of the year, he told me, hey, let's do the boot camp. He was unlucky. He came up with the idea of the boot camp. And he was also afraid. He was confused. And I was like, no problem. I didn't agree at first, but eventually I saw reason. I was like, fine. Even organizing this boot camp, he still doesn't know. He hasn't competence with what has happened now. One of the two things, this same Ebuka that almost left NSK the AI reached out to me that he wants to be the leader of NSK AI, and I said yes. And I watched this young man grow and grow to be the leader he is today. So this is like me giving him his flowers, but I'm saying this for people who this is the beauty of
You're saying it as if you are my dad.
I'm sorry, I'm not your
Yeah,
father.
you're
Maybe,
saying
but
this
it's
guy.
been beautiful watching you grow. No,
Ifeanyi
it's
is
a
my
thing of
guy.
joy
Don't
for me.
mind
You know,
him.
because I'm the one watching you. Yeah, but for anyone who's thinking about joining, yeah, being a part of this community is going to be difficult because it's going to stretch you, but it's worthwhile and you're going to grow as a person. And I think we're doing great things. I really can't see the entire end of this community, but it's been a worthwhile journey. And so this is me marketing. Anyone that is thinking of volunteering, we have leadership positions available. We have less intensive positions available. I inform you guys here. So yeah, that's everything for me. I'm sorry we already past time. It's 7:30. I mentioned 7:30. If I don't know, do you have any other thing to say?
Nope. If you have any question or confusion, let me know. Discord. And yeah, if you want to volunteer or work at NSK.ai, reach out to me, reach out to Ifeanyi. It's an opportunity for you to grow. That's what Ifeanyi is trying to say.
Yeah.
Have a great day, guys.
Sumaya, Mike, Rose, Bisola, you guys cannot be four in a team. It's three. It is three people in a team, not four. Three of you must be from three different countries. I know Rose is from Kenya, Sumaya is, I think, from Ethiopia, and then Mike is from Nigeria. So, yeah, but you guys figured it out. So, take care, everyone. Bye. Good night.
Good night, everyone.